Hey guys, welcome back everybody. So let's get started with the basic troubles, not basic troubles today, the basic lab of the IPv6. So here we gonna learn about how does the ARP is gonna work in the IPv6. It's totally different with the IPv4. Normally, if you remember that in IPv4, what happened? If you have a PC1 and if you have a PC2, right? So to example, we have PC1 and PC2. So normally in the IPv4, what happened? We have IP address for those guys are 10101. Okay. And the MAC address for those guys are, take example, we have A for those guys, right? So for the PC number 2, we have a MAC will be B and the 112, right? So the PC1 we have and the PC2, and then we have a Ethernet cable that's gonna provide the connectivity between this guy to this guy. That's called as a wired media concept. And every PC does maintain the ARP tables. For example, the PC ARP table, we have this one, and the PC2 ARP table as well, we have, right? So as we know that if I'm gonna ping right from the PC1 to the PC2 10112, right? Normally what happened, the PC will create a packet. In that packet, what happens? So we have a source MAC will be A. I have no idea with the destination MAC. Okay, then with the source IP 101, destination IP will be 102. So eventually what happened? Eventually the packet will be dropped because we don't have a B MAC address, right? So normally in that case, what happened? The PC1 will generate the ARP request packet. In that ARP request packet, what happened? If you see that, you have a ARP request. So in that ARP request, we have a source MAC address, destination MAC address. So let me do that this way. So we have a source MAC, we have a destination MAC, right? And then we have a source IP and destination IP, right? This is how the ARP request looks like, right? So this is the Ethernet header we have. And this is the ARP header we have. So in this Ethernet, we have a source MAC will be, take example, we have A and destination MAC will be FFF, right? That's going to represent that it's a broadcast packet. And then finally, we have a source MAC will be A again, and the destination MAC will be 000 because I have no idea, right? And then source IP will be 101, destination IP will be 102. So normally what happened in that case, the PC1 is going to generate the ARP request packet. This ARP request packet is a broadcast packet. This ARP request packet is a broadcast packet, right? So right now I just have two PC, but take example, if you have an in-between switch over there, and then this switch is going to connect with the switch 2, and then switch 2 is going to connect with the 1000 host over there. Understand this concept. And the switch 3 as well we have over there. And the switch 3 is going to connect with the router as well, and switch 3 is going to connect with the switch 4. And the switch 4 also going to have a 5K host. So this ARP request packet will comes to the over here, this will go over here, this will go over here, and there, and there, everywhere. That's a problem we have in the IPv4, because IPv4 does have a mechanism of the broadcasting, right? So this is how the packet comes to the PC2, and PC2 will receive this packet. It will update the entry in the ARP table. So the 101 associated with the MAC will be A over there. And now the PC2 will get the reply packet. In that reply packet, we have also again source MAC, distance MAC, right? We have a source MAC, we have a distance MAC, we have a source IP and destination IP over here. The source MAC will be now, in that case, will be B. The destination MAC, of course, I can get the information from the ARP table. We have a. Same way here, we have a B and A, right? And then we have a source IP will be 101, sorry, 102, and the destination IP will be 101. So this is how your ARP reply will be there, right? So the good part of this guy, the ARP reply, we have a unicast packet, right? This is again my Ethernet header we have. And this is my ARP header we have. So this ARP reply packet comes to the PC number 1. And then again, the PC number 1 will create the entry in the ARP table, say the IP and the MAC. The IP will be 012 and the MAC will be B now. So this is how the IPv4 works. So if the PC does not have a MAC of the destination person, so they will do the ARP request and the ARP reply. The ARP request is always to the broadcasting. That's the biggest issue, right? So in comparison with the IPv6, right? In comparison with the IPv6, just give me one, let me have a water, please. I don't know what happened to my voice. So in comparison with the IPv6 now, we have a PC and another PC we have, take example, right? And understood this concept right now. The PC1 has a MAC address and PC2 also has a MAC address, right? And the PC1 we have, PC2 we have. The IP of this guy, of course, the IPv6 we have. Let me decrease the size for this one, first of all. I'll configure this guy as a global unicast address as a DB8, right? It's a hex format. And the cafe we have, then I'll call this guy as a 00001 and colon 1/64. So same thing, I'll configure this guy as a MAC address as well. A of the, so I'll configure the PC2 as well over here, right? I do have a, so in that case, the PC does not have a ARP table. We don't have a ARP concept in the IPv6. We do have a something called as a ICMP packet. Under the ICMP packet, we have a multiple types of masses. The most important masses we have over there is called as a neighbor solicitation masses. Right? And the neighbor advertisement masses, NE. Apart from this thing, these two masses, we also have some other type of masses in the ICMP that we'll discuss in the CCI label, like a route advertisement, RA, right? Route solicitation, we have then we have a redirect masses, right? So we have these types of masses. We'll discuss this in the CCI label. But the most important thing that you need to understand over here, the basic label, the neighbor solicitation and neighbor advertisement. Before I'm going to explain you the meaning of these two terms, the neighbor solicitation, I'll just include the meaning of these things on the Google. If you just go on the Google and check the meaning of solicitation means what, you just need to find the get something from my neighbor, right? The meaning of this guy is what? Get something. If you just go search on the Google, the meaning of get something means what? I just need something from my neighbor. I just need something from my friend. I just need something from my client, anything, but I need something. So in that case, what happened when the PC1 will try to create a ping packet? He says, hey, I want to send the packet to this guy. Guys, someone mic is on, please be on mute. DB8 cafe 00. Oh, my bad. 1 minute. It should be 2, right? And what happened when I said the ping 2 over there, then what happened? In that case, the PC1 will look up the IPv6 neighbor table. It will not look up the ARP table. It will look up the IPv6 neighbor table. And in this IPv6 neighbor table, what happened? He will find there is no entry for the B, or we can say that there is no entry for the PC2, right? There is no entry for the PC2. In that case, what happened? The PC1 will request to the PC number 2, hey, you know one thing, I need a MAC address of you. In that case, the PC1 will generate the neighbor solicitation message, NS message. And in this NS message, what happened? He will request to the PC number 2, hey, please help me with your MAC address. So once the PC number 2 will receive this information, they will update the IPv6 neighbor table, and they will give the reply to this person with the help of neighbor advertisement message, NA message. This is also comes in the NDP protocol, neighbor discovery protocol. So NDP, under the NDP, what happened? You have a neighbor solicitation and neighbor advertisement message. So let me show you this thing in the practical in the GNS3 with the Wireshark capture. Then you will understand more clearly. But make sure that in comparison with the IPv4, these masses that you can see that NS and NA masses, these masses are the multicast, not the broadcast. These masses are the multicast, not the broadcast. So this masses will only listen by the particular client and particular user who has joined the multicast group, not to the every person. That's a beauty you have in comparison with the IPv4. So here you don't have a concept of the ARP. Here we have a concept of the NS and NA. And here we don't have a ARP table, we have IPv6 neighbor table. So if you have a look in the GNS3, let me show you the practical. Then we'll go through the lab as well. I have created the lab for you guys so that we can save the time. So here we have, oh, come on. Here we have a lab on my server right now. I just did the lab in the morning. So we'll do this lab for the static route for EIGRP, OSPF, and BGP2. So all the routing protocol lab, we'll do that over here. But before I'm going to do that, I'll show you the neighbor solicitation and the neighbor advertisement, the NDP protocol. So here you can see that I have a 2001 DB8CA Cafe 1. That's a network portion we have. The same network I have over there. This is the host IP address. So I'll configure the 101 and configure the 1.2. So they're separated by the colon that we have discussed yesterday, right? So the IPv6 addresses are separated by the colon, double colon, and these are in the hex format. So if you want, you can configure this interface as a 12.1 as well, the IPv4 addresses. So if one PC has configured with the, understand this concept. Okay, if the one PC is configured with the 2001 DB8 Cafe, right? And I'll say the 00001:1/64. At the same time, this PC also has a configured with the 1-to-1. This concept, it means that the PC can support the IPv6 and PC can support the IPv4. This concept is known as a dual stacking. So if the PC does support the IPv4 plus IPv6, the concept is known as a dual stack. So you do have ability, you can do the same configuration on the router as well. But by default, as I told you that if you don't configure the global unicast address, by default, what happened? Your PC, whatever the PC is now coming, whatever the devices are coming nowadays, all they are capable with the IPv6. So automatically they will get the link local address. So if you just have a look in my computer as well, CMD, and if you just put the command ipconfig/all, you will see that I do have a IPv6 address, that's a 2402, and then we have a link local address as well for this FE80. If you go with the other VNet, I have a link local address FE80 at the same time. Do I have a global? I don't have a global over here. That's fine. But by default, link local will be present just to provide the LAN communication. So everywhere you will find the link local address. For this guy, I don't have a global unicast address, but I should have a link local address to just maintain the communication in the LAN network. And that's a good part of the IPv6. So have a look. Let's configure the IPv6 address on the router interface. How you do that? You just need to go under the interface. If you want to configure the IPv4 as well, you can configure it. For example, I say the 12.1. And that's fine. So on a single interface, I can configure the IPv4 and the IPv6 as well. For the IPv6, I just need to put the command IPv6 address and the 2001 DB8 Cafe, and I'll say the 1:1. So till this point, we have a 64-bit, right? And this is the IP addresses that I'm going to do. This is the network portion we have, right? And this is the host portion we have, then /64. No shut. Same thing, same subnet IP I'm going to configure on the router 2 as well. Interface 0/0. IPv6 address 2001 DB8 Cafe. So if you configure the 0 deviate, that's also fine, right? Because this 0 will be omitted, right? Yesterday we have done this part. The leading 0 can be removed. Cafe and as the 1::2 and /64 over there. No shut. I'll also configure this guy's IPv4 address as well to allow to. So if you see that on this particular address, on this particular interface, you have three addresses now. One is called as a IPv4, another is called as a global unicast address, and the third is called as a global unicast address. That's for the IPv6. Then you have a global unicast address. That's for the IPv4. At the same time, we have a link local address. So we have three types of address on this particular interface right now. So if I'm going to configure the IPv6 address, the global IPv6 address, automatically what happened, the router will get the link local address as well. So if you see that do show IP interface brief, this command will show you the IPv4 configuration. But if you put the command do show IPv6 interface, it will show you the v6 configuration. So if you see that in the configuration, what happened, I just put the 0 deviate. What Cisco router allow you, it will reduce, not reduce, I can say that it will remove the leading 0 from there so that it can make a sorted address. It will it will summarize the address in the short format so that you can easily deliver it. So if you see the 0 I have put in over there, but 0 is not showing in the config. That's a good part, right? So what I can do that, let me copy, take the snap of this one so that I can capture the Wireshark and show you in the paint file simultaneously. So you will understand the NDP protocol, or we can say the neighbor solicitation and neighbor advertisement in the single page. And what I can do that, I'll capture this link, copy and capture. And hold on. So I'll say that end 1 minute. Reminder me later, and so the ping 2001 DB8 cafe. And I'll say that what was IP? It's a 1:2, my neighbor IP. That's all right. So I'm on the router 1. Router 1 have a 1:1. Router 2 have a 1:2, right? So I'm pinging from router 1 to router 2. So I don't have a MAC address for this one. If you see the show IPv6 neighbor, I don't have. So I'll say the ping DB8 cafe 1:2 and have a look. I have a neighbor solicitation. I'll take a capture of this one and I'll paste it in the paint. Then we'll discuss this thing. Here we go. So the good part, it's pure, what do we call? Multicast way, not the broadcast, like we have in IPv4. And then neighbor advertisement that we have. All done. Capture. And here we go. All good. So if you see right now, so router 1, that has a source MAC address CA0313C, right? That's a source MAC address we have. Destination MAC address is the multicast MAC address, start with FF0. The starting point is the FF means what? It's a multicast address. You can see the source address will be 2001. That's a DB8. That's a global unicast address, right? And the destination address is the multicast address. Here we have a source address is the same one, the destination multicast address, not the broadcast one. And here we have our neighbor under the ICMP, we have a neighbor solicitation message. The type code is a 135. This code will be changed depending on the message type. For example, if you see the neighbor advertisement, we have a type code is a 136. If you go with the route advertisement and route quotation message, the another type of ICMP v6 message that has a different code value as well. So if you see that in the ICMP v6, what happened? The target address for this guy is 1, 2. So R1 is looking for the 1, 2 address. So in the response that you can see that the response is a pure unicast packet. It's not a multicast. And in the response, you can see that I put the own information on linked layer address. That's a layer 2 address. So router is sending the neighbor solicitation masses, and neighboring router is going to advertise the neighbor advertisement masses. And that's how your ARP, not ARP, we can say the NDP protocol works in the IPv6. Here we don't have a ARP concept. Here we have a concept of the NDP. So if you bring the 2 or 2 right now, it will generate the ARP. If you see that, ARP comes in the picture, but this ARP is a broadcast packet. That's a major difference. You can see that. So if you see, the same request is a multicast, but this is the IPv4 mechanism. In the IPv4, we have a broadcast mechanism. Same, we have a request packet, but this is the multicast mechanism we have. That's a major difference. If you put the command show IPv6 neighbor, previously it was not showing anything. I do have my information. That's a good part we have. So we did the practical of what dual stacking. So on a single interface, I configure IPv4 and IPv6. So IPv4 user can communicate with the IPv4 address, and IPv6 user can communicate with the IPv6 address as well. Guys, anyone has a question in the basic part? Is it all clear?
Yes, hi. Sorry, I have a question. I mean, you configured the IPv4 and IPv6 in
Single
the same
interface.
link
Yeah.
in single interface, correct? Yeah. So
We do
is
have
that is that it's called what? Like
dual stacking.
sorry, it's called what?
Dual stacking. So when
Dual stacking, right?
when
Right.
host support both IPv4
Mm,
and IPv6, this
right.
mechanism is called dual stacking.
Is that the similar when we stack the cables on behind the switches?
That's called as stacking. That's called as switch stacking. That's a
That's a
different
different stacking.
stack.
Yeah, that's a different stacking. Right. So
But
if it
the
is
meaning is stacking. The meaning of stacking is what? Putting one to another, right?
correct, yeah.
That's the meaning of stacking. So we already have one thing. I'm putting another thing over there. That's called as stacking.
Yeah. So it make it one single interface, right? Okay, so in this specific case, if you just remove, if you just run one IPv6, we don't run the IPv4.
If
So
you don't want to run the IPv4, you can remove the IPv4 as well. That's fine.
that will be just like a normal
Normal.
IPv6
So if
configure.
I just go on the interface and I'll say, hey, one thing, I don't like to configure the IPv4. So the no IP address for there. So normally what happens, this command will remove the IPv4 address. So if you see the do show IP interface brief, I
Right.
don't have a IPv4. But if you see the do show
Yeah. Mhm.
IPv6 interface, I must have IPv6 over there.
Sure. It is, I think the basic concept is a little bit similar to the Ether channel, isn't it? When we bundle the links
Oh, that
together in
see, we can comparison, right? That's fine. But don't compare like Ether channel and those things because the concept is totally different. Here, the in a Ether channel, basically we are doing the bundling of the link, right? Here we are not doing the bundling, right? We here what happened. So take example, understand in this way. There's a one server that has a IPv6 configuration, and there's a one server that has IPv4 configuration. In that case, what happened? Your router must forward the IPv4 packet and your router must forward the IPv6 packet. In that case, what happened? Your interface must capable to do the IPv4 and IPv6 as well, right? Understood the concept? Got that? Nasir, you understood? All good?
Yeah, that's fine. Yeah, sorry, I was on mute. Yeah, that's fine. Thank you so much. I got it. Thank you.
So if you're, see, understand in this way, if you have a requirement of the IPv6, you have to do the IPv6. If you have a requirement of the IPv4, you have to do the IPv4. But if you have a requirement of the both the server, IPv6 plus IPv4, then your router must support the both the flavor, right?
It has to be the uh, multifunctional router, right?
Yeah, that's a one thing concern. So whatever the 64-bit CPU is coming nowadays, they all are supported with IPv6.
And they also support the IPv4 at the same time.
Because IPv4 is the obviously. The 32-bit CPU, I think so they are not supporting the IPv6, but the 64-bit CPU support the IPv6.
IPv4 and IPv6. It's like a multi-layer switch, layer 3 switch. It supports.
Yeah. Yeah,
Yeah,
yeah, you're like multi-layers do support the routing and switching as well. Yeah, yes, you can say that.
I'm I'm comparing too many things today.
Yeah. You're comparing the many things. Okay, let's come over there, man.
Mhm.
Let's
Wait.
do this lab. So what I can do that, I'll start this node first, wipe this node all because IP is configured already. And I'll start this all devices. I'll open the notepad for you so that I can save this notepad eventually to everyone so that you, if you want to do the lab for this guy, you can do the lab because normally the IPv6 is little complicated and normally people are not used to do the lab of this thing, used to of the IPv6, right? So you can follow this config file. So in this notepad file, you will get all the labs for the EIGRP static and IP configuration, the what we call the BGP to host as well. So in the router one, if you see that we have this router, so I'll also config terminal mode interface gig 0/0. I'm only going to configure the plain IPv6, no IPv4. IPv6 address we have. So this is the subnet that I can see that it's if you see that, so the okay, there's no why it's not coming. The my resource coming. Yeah, that's fine. So if you see that in this section, or what happened this between the router 1 and router 3, we have a 0/1. Router 3 and router 4, we have a 0/2. Router 4 and router 5, we have a 0/3. Router 5 and router 6, we have a 0/4. And router 5, 6, and 2, we have a 0/5. Right? So remaining the 48 bits are all same. Only the changes is happening in the fourth. I cannot say the octet in the 4 hex one. Right? So let's do the lab. IPv6 address we have 2001 DB8 cafe and also the 00001 :1/64. That's for the router number 1. Also the no shutdown on router 3 as well we have. So on a router 3, I'll just copy and paste this configuration. I'll make this guy the host name as well, R1. Copy in R3 as well we have. On R3 also the host name is R3. On a gig 0/0 will the same subnet, only the IP address will be according to the router name. R3 will be 3. Same thing for the R3, this interface, gig 0/1 now we have. It should go with the 2:3. Now we have a router 4. Router 4, we have a router 4. Router 4, we have a, this interface will be 02:4. And this interface will be 0/1. It's a 03 and 4 according to the router name. Then we have router 5. We have router 5. What this guy will do, the router 5, this interface 03 5 over there. And this interface will be is 04 colon 5. Then we have router 6 now. On router 6, we have a 04 colon 6 and 0. Did I configure 0? Okay, 5 and colon will be 6 over there. And then router 2 we have finally. I don't need 0/1. Great. Bless you. 2 over there, and this will be 5, and this will be go over there. It should be the 2. So if you see that on this particular subnet on the router 2, I have configured the 05 and 2 over there. So the basic IP address part is done, right? What I can do that I'll just copy and paste this configuration right on all the router. R1. R2. R3. R4. R5. R6. And that's all we have. No, 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 no. Copy. On router 1, we have all done. Router 2, we have, sorry, router 3. Router 4, we have. There's a few concept of the, IPv6, right? Where like a NAT problem is there in the IPv4. But again, that problem you will only understand when you have a good knowledge of the IPv6 protocol, right? So that you will understand in the CCI level. So we have a good discussion on IPv6 in the CCI part. But yeah, I'll cover all the routing protocol over here in the NP level as well. Don't worry.
But IPv6, I'm sorry to interrupt you, but IPv6, understand it is it's good to learn, but it is not that
It's
important and
not that
mandatory.
you can encounter in the production input nowadays. The reason is that people are not getting the lots of issues in the IPv6 nowadays. They are only getting the issues in the IPv4.
In terms of interview and job prospects. So it's not that important to learn very, very deeply, right?
But again, knowledge is always important.
Obviously, yeah, that's true. Because it's a little bit
Even if I
tricky
talk about
then.
the CCI lab exam perspective, in the CCI lab exam, what happened? You will only have a two marks of the IPv6 question.
Sure,
Okay.
that's
So
good.
that you can solve max to max in the 20 minutes. The CCI lab, if I talk about, right? So basic questions are coming in the CCI lab, like they will ask you to configure the IP. They will just give you the 4 routers of the lab. Okay, they will ask you to configure the IP addresses. Many times the IP address is already configured. Only the wrong IP address system, you just need to correct it. And the basic routing protocol, you just need to apply it. Maybe the OSPF, maybe the AGRP, or maybe the BGP. Any one of them.
That's
So with
that's
that
right.
being said, I'm sorry, I didn't mean to interrupt you, Nasir bhai.
That's okay.
No. So I mean, I was just wondering while all this we were learning, like how having knowledge and skills of IPv4 and IPv4 subnetting and supernetting and all that. I wonder with so many IP addresses with IPv6 and the simplicity of it, if that would play any role in terms of desired skill sets in the market. You know what I'm saying?
Yeah, I got the one. So I'll tell you one thing, Biru, right? So
Yep.
do you know what happened? I'll personally tell you, I've given many interviews, right? I have never encountered the IPv6 question, first of all. So the people who were the judge you, right, in the market, they will judge you based on the IPv4 only, not the IPv6. But again, it doesn't mean that you're not going to learn the IPv6.
No, no, understood. No, I'm saying I'm thinking in terms of future market requirements.
Future
In
market
terms of like,
requirement, you need to wait for the, I think, some more 5 years when the IoT
okay,
comes in the picture. So I'll tell you, yesterday I gave the one example, right? So what happened, I bought the one washing machine at my hometown, the almost 20 days back, and this is the IoT washing machine. So I can operate that washing machine from anywhere in the world. So
right,
for example, my mom is sleeping and I can turn off washing machine from here only, from Noida location, or maybe the Bangalore location as well, right? So that's that's all they are associated with the IPv6 addresses. So nowadays, like, people are planning to, they can make a complete home, like a advanced level of home, AI based enabled, so they can operate the devices from anywhere to anywhere. Because, I was reading one of the book and I found, you know, right now, per user have a 3.5, not 3.5, it's approx 3.64% devices per person. So you can conclude it like almost one person is having a 4 devices nowadays, right? Nowadays, if I'm talking 4 devices, one person. So it means that one person
right,
has 4 IP addresses. Doesn't matter you have IPv6 or IPv4. Of course, we are done with IPv4. So of course, they have IPv6 addresses. So people, you will see the, like, use case of the IPv6 very soon, maybe the 3 years or maybe the 4 years, because all the ISP is migrating with IPv6 nowadays. All the ISPs, even the Facebook, the LinkedIn, the big companies, LinkedIn, Facebook, Twitter, they are all running in the background with the IPv6. But but you have to wait for the, like, the troubleshoot and the cases for the IPv6, maybe later, maybe the 5 years or 6 years. Then right now you will always get the cases of the networking on the IPv4, not the IPv6. So yeah, use cases will become, but if you have a good knowledge right now, that will be good. So is IPv more secure? Of course, because IPv6 has a IPsec protocol optional. So in IPv4, what happened? You need to configure the IPsec protocol to secure the data traffic. But in the IPv6, what happened? We have a IPv6 IPsec header over there. So it's pure secure. Of course, we don't need a NAT concept. So basically what NAT is doing that, that's I told you. So NAT is related to IPsec protocol. You will understand more things in the CSI level class, but I explain you how the NAT create a problem in the IPv4. First of all, whenever the NAT devices receive the packet, it translate the source IP, right? At the same time, sometimes it also translate the destination IP, depend on the situation. And whenever the return packet is coming to the NAT device, NAT perform the translation lookup. It will perform lookup in the translation table, and again it perform the translation, right? And then it will send the packet to the user. So understand the concept. So always the NAT router is going to do the translation. So your delay comes in the picture, and they break the integrity, because changing the IP address from one IP to the another IP means what? Someone in the middle is breaking the integrity of the packet. So IPv4 is not as secure than IPv6. So IPv6 is more secure. And that's why the coming days, whatever the things are coming in the IoT devices, they are all running with IPv6 nowadays. Understood why?
got
Yeah,
it,
that's
got
fine.
it.
Yeah, please. Thank you.
Okay, you guys put the question. Meantime, I'll just configure the router. Okay, you guys go ahead and put your question. I think so. I'm done with IPv6 addresses configuration. So let's do the routing part of the IPv6 routing. So on the router one, what I can do that, I'll configure the static route. Before I'm configuring the static route, you first need to enable 2 things. So first enable IPv6 unicast routing. so that router can forward the IPv6 packet. Also enable the IPv6 SEF, because by default this mechanism is disabled. So how you can enable it? So on the router 1, router 2, router 3, router 4, router 5, and router 6. You can see the IPv6 unicast routing and IPv6 SEF. So if you're not going to enable this command IPv6 unicast routing, then what happened? Your router interface where the IPv6 address is configured, they will treat like a host addresses. So they will never forward the IPv6 packet. They will just receive it, process it, that will fine, but they will not look up the routing table. So this command is mandatory to enable it, to do the routing. Next command is what we need to do the static route. The static route you can do in the 3 ways, like we did in the IPv4 as well. But here's a little bit tricky part comes over there. So the syntax is what? IPv6 route. So I'll show you the first ways. You can do the lab in the 3 ways as well. Destination network, then you have a submit mask information as well. Then you have a link, not link local, yeah. You should have a link local address. As a next stop. And then you have exit interface, because link local address require the exit interface. So even if you're not ping the link local address, you need to put the exit interface in the ping. The global unicast address doesn't require to use the exit interface. For example, if you see, if I'm going to ping from router 1 to router 3, cafe 003, which is the IP address for this guy. I can easily send a traffic, right? You can see that. But let's take example. What is the IP, like, link local address for the R3? Have a look. The link local address for this guy is FE80. That's for the gig 0/0R3. If I'm going to ping this guy, it will ask you what is the output interface we have. So you need to type the gig 0/0. The full interface name you need to put the giga. I think what is the gig Ethernet icons like gig. Oh, so full interface name. Let me check. It's a gig 0/0. Full name we need to use. Okay, it's a giga. So let me ping again this guy FE80 and output interface is out. What happened? Packet send the source address FE80/001 is not ping. Why it's not ping? It should be ping, man. Yep, it's working, right? So you need to use the exit interface when you want to ping the link local address. That's very, very important. So let's have a look at the first ways to configure the static route. Right? So what you can do that on the router one, if you see what network I don't have on router one. On router one, I do not have this network, this network, this network, and this network, and this network as well. So you can configure all the network you have. So on router one, I said the IPv6 route. Destination network will be 2001 DB8, cafe 0002, and that's all. 64. Then the link local address will be my R3 link local address will be that's this guy will have ping this person. Where's that man? You can also change the link local address if you don't want the big one. You can do how it is changed. Yesterday I'll show you the practical of this thing if you remember that. And the gig Ethernet 0/0 as well. So this is a command to configure the IPv6 static route on the router one. If you see that. What happened? BB8002 and /24. Yeah, so the not bad. Yeah, so this has to be changed. This will go the last. So syntax is a little different, man. Okay, so that's how you can configure the IPv6. Same thing for the another person. So I need to configure the how many? So I need to configure the 3, 4, and 5 as well. They will use the same link local address for everyone. For the router 2 right now, man, router 2, we have a, on router 2, if you see which address I need to configure it, on router 2. On router 2, if you have a look, large, not router 2, let's do the router 2 as well. On router 2, we need to configure the 4321. So 4321, I just need to change this guy. That will be fine. And the same interface exists 0/0. What will be the gig 0/1 link local address? So let's go on the R6 and let's have a look for the do IP interface brief. This one. The little complicated, not complicated, I can say that number of addresses is little in the hex format. That's why it's hard to configure it. R2 is done, man.
Sorry, in R2, the static root is 4, 3.
3214, right?
No, I'm talking about the router 2.
The router here is the router 2. So router
Yeah,
2 does
but
not have a 4, 3, 2, 1. They have a 5, right? This is directly connected.
how come it's itself? So 4, 3, 2.
In a static
So
router, you only need to define the route which you don't have in your routing table. Right?
which one is the two one in this sentence, in the syntax?
Which one is
Uh,
this one? I'm on the router number 2, Nasir.
mhm.
Router 2 already have a 5, right? Which I don't have. 4321. I define the 4321.
Yeah, so that's what I was saying. So 4, 3, 2, 1. What about 5 and 6?
What, do I have a 6 network over here? No. Do I need to define the 5? Because 5 is directly connected. Why do we need to define the 5 in the starting route?
No, the
Revise
directly
your
connected
starting
to the
out. Revise your starting out concept, Nasir. You're missing
no,
the app.
no. What I'm saying is the directly connected is the 6.
Where is the 6 network in the diagram? Can you see the 6 over there?
Yeah, 1, 3, 4, 4, 5. The directly connected is 6, isn't it?
Of course, 6 should not be there, right? You're not getting the point? What happened? Tell me.
Yeah, R2 I'm talking about.
Sorry?
I'm talking about the R2, not
Okay.
R3. So the 6 is directly connected to the R2, isn't it?
6 is directly connected with the R2, right? This network.
Yeah.
So do I need to define the route for this network? No.
Even 5 is also not advertised. 5 and 6 is not advertised
Where is the
in
6
router.
network? Where do you see the 6 network? I don't see the 6. Where do you see the 6 network? 6 is the
So
route name. There's no 6 network we have in the diagram. I have a 1, I have a 2, I have a 3, I have a 4, I have 5. Where is the 6? You see that.
right on the top, next to the router too.
That's a router number 6, not a network. Are you confusing with the network and router? That's a router number 6. Name is the router 6. There is no network 6. This is the network portion. This is the router name.
So we have 5, 4, 3, 2, 1. Is
That's
that
all.
right?
Yeah.
5, 4, 3, 2, 1. Okay, so and 5 we cannot advertise as directly connected.
Because it's my directly connected route.
I see. Sorry, I was confused with the machine as well.
No issue. That happens. I told you that IPv6 is a little like a puzzle for everybody. So on the router 3, man, which route I don't have. On router 3, I already have a 2 and 1. That's my directly connected. I don't need to do that. I do the 3, 4, and 5. So I did the 3, 4, and 5.
So in
The yeah, go ahead.
sure, just one moment. Let me have a double check. For router 3, where is 3?
Router 3 is router 3.
Uh-huh. Yeah, that's fine. So in that case, the directly connected is 2 and 1, right?
Okay,
So rest is 3, 4, and 5 we need to advertise.
that's perfect, man. Which interface I need to use? Give yours last one, right?
Yeah.
Exit interface. And what will be the link local address for the R4? That's my next stop. This will be the link local address for the R3, right?
Uh,
R4.
the, the, the next hop will be this link.
The link local address for the R for this interface.
This is the next hop, right? Where
Right.
your arrow is.
You need to
G0.
go. Yeah, gig 0/0 on the R4.
That's the next hop, right? Got it. That's why we are planning for CCA to revise everything.
Oh man, happens. Happens with me as well.
Yeah, after 5 years, it will not happen.
Boss. On R4, which network I need to do that, man? Tell me.
On R4, the directly connected is
3 and 2 and 3 is directly connected. So in the R4, we need
That's
to do
correct.
that.
Okay, let me tell you,
Yeah,
please.
take your time. You tell me.
Okay, so in R4 we are need to advertise 1, 4, and 5.
1, 4, and 5. That's all right.
Yeah, that's correct,
For
isn't
the
it?
yes, exactly. For the R4, for the one side, you need to use the gig 0/0.
Mhm.
And for the R4 for this side, the link local address for the R3 gig 0/1.
Mhm. So here we are now. We are now. Yeah, that's fine. Yeah,
Right now.
yeah.
And R for this side, the 4 and 5, the link local address of the R5 0/0. And the interface is
It's,
0/1.
so the link local. The next hop is again for the
My
R4
neighbor
is.
link local address. So for the R4, who is my neighbor? This is my neighbor. What will be the link
Your
local address for my neighbor? Gig 0/0 interface.
G0/0, right?
Right.
On which is on R5,
Exactly.
and on left hand side R3 is the link address. Local address is G0/1.
Right, so. Now you understood?
Yeah, that's fine. Okay, great. So yes.
On a R5, which network I need to do that?
Okay, let me tell you if you don't mind.
Yeah, you go ahead.
Okay, on R5, you're directly connected is the 3 and 4, right?
Okay.
And you need to advertise the uh, 5, 2,
5,
and 5, 2, and 1. Okay,
1,
yeah,
and
yeah,
then
you need to, yeah, that's it, 5, 2, and 1. Yeah.
5 to 1. Perfect. So for the
Uh,
this side, let's take example. You are sitting on the R5. Now you need to
mhm,
go on the this network and this network. So the exit interface will be gig 0/0. That's fine, right?
mhm.
Right now.
Sorry, sorry, again?
For this side, if you want to go to the what 2 and 1, so the exit interface will be gig 0/0. And my link local address will be y R4 0/1 address, right?
Yeah, your link local address is 0/1 and
The R4.
0/0. Yeah, yeah, on R4, yeah, that's great.
However, the R5 this side, my interface will be gig 0/1, R6 0/60 IP address.
Sorry, on R5, you need to advertise the 0/5 and your
My
link address is 0/1.
0/1 will be the exit interface and the link local of the 0/0 of the R6.
The link local is 0/0, but the exit interface is 0/1.
Right.
That should be in the configuration.
Exactly right.
I see.
On a R6, which network I need to do that?
So in R6, if you say you are advertising the 3, 2, and 1, right?
Perfect.
Okay. And your link local address is on 0/1 on R5,
R5.
and
Perfect.
and on R2 your is the 0/1, right?
Perfect. 0/0.
And sorry, 0/0, and your exit interface is 0/1.
Your exit interface will be 0/0. Your link local address will be R5 0/1.
No. I'm on your link. Yeah, no, I mean your link local address will be 0/1 on R5,
Okay.
but your exit interface will be 0/0 and 0/1, correct?
Why is 0/1?
Is
You
because
have to go on this network, and this network. So you will go from the 0/0, not the 0/1, right?
No, if you want to go to the R2,
Why
let me
you
know.
go to the R5? This is my directly connected network. Why I don't need to? Why I have to go on this network?
I see.
Understood?
Okay, so on directly network, you don't need exit interface.
Because if you have already my number, why you gonna ask the number of mine to someone, right?
So you just have to focus the link local address. That's it, which is
That's all. That's all.
and the link local address is the it's a 0/1 on R5, right?
Always my neighbor one.
Always and on R2, what is the link local address? Is 0/ confused here. 0/0/0, I believe.
Why you are going for the this? Okay, you tell me one thing. On a
No, I'm talking
R6,
about the
on a R6, which network you don't have?
on R6. You don't have 4 and 5. You don't need to
You
advertise it.
have
These
a
are
4
the
and 5 that's a directly connected.
yeah, correct. Yeah,
You don't have 3, 2, 1. So
yeah,
you
correct.
just
That's right.
install the 3, 2, 1.
That is fine. I understand that. Okay. So, but 3, 2, 3, 2, and 1. Okay. So if you want, say, if you want to advertise 3, then the will be the if you want to advertise the
If you
3,
want to
then
advertise
the
the 3, 2, 1, so exit interface will be 0/0 of the R6, right?
0/0, which is his own interface, right?
Right on interface, perfect. And the link local address will be R50/1, right?
The link local address will be the R5, which is the 0/1.
Right,
Right. Okay. So that's for the R3 and for the R2. Again, the link local address will be the again 0/1, if I'm right.
right.
And and your exit interface will be
0/0.
again, I see.
Now you got it?
And the same for the uh,
1.
R1. The exit interface will be the zero exit interface with the 0/0, and the link local will be 0/1.
Right. Link
Okay.
local always will be your neighbor IP address. That's fine. 0/1.
So we just have to basically the 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 thing need to understand is you have to look the neighbor interfaces basically.
Right. That's the meaning of link local. My neighbor next hop IP address.
The closest one. One is your own interface where it's directly connected. That will be your the exit interface, and then you are going to the whichever is the next one. That will be your link local.
Right.
It's same as you leave the room. So your the door you are going to be coming out. That is your obviously your exit interface.
Now you understood?
Yeah, that's fine. Yeah, got it. Thank you so
It's
much.
just need a practice, man, nothing else.
It's just yeah, just a practice and listening the video a few times and should be fine.
If you see that I do have a static route for all the network now.
Right. So this is the static route in IPv6. So what about default route?
Same way you can configure the 0/0 and you can configure the default route as well. So I will ping this guy 2001 DB8 cafe 005 colon 2.
Right. That's fine. That's great.
Not great, man. I'm not able to ping. Why not? So let's ping my neighbor IP address first of all, DB8 cafe 001 colon 3.
Mhm.
I'm able to ping it. How about the 2:3, ping it 2:4. Not, why not? Why not?
You are not able to ping to the 4, right?
I'm able to ping to the my this router, but not to those. So let me check what's the mistake I did.
Sure.
So 4 and 5 gives you /0 and 3 0 3. And it's correct, right? The mistake I did, man. If we had 0 R3, I did this time with the R4. We show IPv6 lab. 2001. I do have the next stop IP80. That's a mistake. I did it, man. So simple mistake. I wrongly configured the wrong interface over there. That's a
Which one?
major mistake. I did it on R4, man. So for this site, it should be 0/, not 1, it should be 0/6. Because whenever the
Oh,
traffic will come over here, it should be 0/0.
so on R4 you made a mistake on
Made a mistake.
when you are configuring the.
Run interface 1 minute. Hold on 1 minute. Let me clarify this one.
Yeah, sure. Yeah, no worries.
Let me correct this guy. Let me check the 140/0, and it's the 5.4 will be, it will go with the, someone mic is on, guys, please be on mute. So this is a mistake that I made to perform on the route of 4. Let me clarify the link local address for the R3 as well. Otherwise, it will create the problem for me again. 3:1. This should be go with the X and for P, and this should be go with the C. That's perfect. So let me remove the R4 first of all. Do show run section IPv6 out.
Sure.
I'll remove this guy 1. I'll remove the all remaining one. I'll reconfigure it again with the correct statement. So R4 now has a correct one. Let me verify again all of them. R1 has look like good. The link local address will be on R3 is give 0/0. FE80 bound, so almost FE03, that's fine. R1 is correct one. Let's verify the R2 now. On R2, we have to go 2, 3, 4, 1. The interface gives 0/0. The link local address with the R6 0/1. R6 0/1. 2/FE80G FE bound, so FE80 One second, 0/0. That's R2 is also good. How the R3 now? R3, I need to go to the 4, 3, 4, 3, and 5. That's perfect. Exit interface will be 0/1, 0/1, perfect. And the link local address will be R4 0/0.
So
Just give me 1 minute.
sure. No worries.
0 round, so and after 0, this will be gate R4, and then R4 we have corrected. R5 now we have. Now R5 we need to define the 2, 1, and 5. That's good. The interface will be for the 2 we have gig 0/0. For the 1 gig 0/0, that's fine. And for the 1 we have a R4 gig 0/1 IP address. FE80, FE0 bound. So FE004 and 1. Perfect. And 0/0 also. R5. That's good. Now, last but not least, we have R6. R6 have 0/0, and then we have a R5. This address. Now it's good to go, and let's ping again with this IP. We're working fine, man. So now I'm able to send the traffic from here to here. So that's our IP address 2001 DB8 cafe 005.2 of the R2 IP. So only mistake that I did on the R4 configuration. That's everything is correct. Yeah, Nasir, go ahead. Only
That's
mistake
fine.
we did on the R4, the link local address mistake that I did.
Yeah, I was looking at R4 as well. So in R4, the mistake with R4, we are advertising for
only the R4 we wrongly configured the wrong interface and wrong link local address. Apart from everything was correct.
Just give me 1 moment, please. I'm looking at the configuration.
Take your time, man.
Just
I'll get my water back. Okay.
on R4, so when we're sending the traffic towards the
Yeah, done, Nasir?
we just please minimize the screen from the top so I can see the interfaces.
Yeah, sure.
That's we're just looking at one router only. The rest will be fine then. Just looking at interfaces.
So proceed, and I'll tell you. On a R4, you're sitting on the R4, and if you want to go to this network, that's a 0/1. Which interface you have to use? 0/0, right?
Yeah, that's correct. Yeah.
And if you want to go to the 0/4, this network and this network, then which interface I have to use? 0/1, right? Understood?
Okay, and what about the
For this site, you have to use this link local address that's I have. And for this site, you have to use this link local address R50/0 that I have.
no, that's fine. So FE03, that is a R3, isn't it? FE03.
Where is 03? FE80 is there, not the 03 is there.
No, I'm sorry, I'm talking about the second last first part. FE03
Yeah,
colon 1.
yeah, right.
Yeah, so there is the
That's for
FE03
the
there.
this one R3 0/1 for this network 0/1.
So the 0/0 is the exit interface, that is fine. And FE301, what is uh, FE FE03? The FE03 is that's the
R3
and
0/1 interface link local
and
address.
I'm talking about the one. What is one?
One
One
is
is
the
just
host
the
IP address.
I see. So just ignore that. Okay, sure. Just follow the 010/0/1/0/00/1. That's it. Simple. Just
Yeah.
okay, got it. That is that's sentence. That's happy.
The second way
Fair
that
enough.
you
No.
can configure the option to outgoing interface using the
Mhm,
outgoing interface, that's the second method that we have,
mhm.
that you can
Sure.
do the lab if you want.
I
So
think
second
one
method we
method is
have,
enough.
yeah, using outgoing. That's why if I'm gonna do the lab, you will again got confused, man.
Yeah, one is enough, I
Outgoing
think.
interface with global unicast address instead of the you know link local address. You can use the global unicast address as the next stop. That's the second method that we have.
Yeah, I think
Also,
everybody
no
understood,
need
right?
to
I'm not taking too much time for other team.
no need to use the link local address. That's fine, Nasir. And third way that we have starting out using only global unicast address as a next stop. No need to define the exit interface in that case. So three methods we have to configure the static. All done, right? Let's remove this all static dot and let's do the EHGRP and OSPF. Right? So on a router one, it will take the maximum 10 to 15 minutes for the EHGRP as well. That's not bad. So do show run section IP root IPv6 route, sorry. I'll remove every one man. Copy. I'll say the no, everyone.
Basically, the concept is same. It's just it's IPv6. That's the only
Everything is
difference.
same, man. Just type use. Few things are different at high level. Basic level, same.
Yeah.
R1 is done. R2. R3. That's why people don't like IPv6. R4 now we have. R5 now we have. R6 now we have. Well done, man. How you can configure the AGRP? So let's have a look. On router 1, you just need to go in the config and move. The IPv6 router AGRP 1, that's autonomous system number. And I'll say the AGRP router ID, you can configure it manually. So next to that, router ID is a 32-bit number. So still in the IPv6, you're going to configure the router ID as a IPv4 format. Because the reason is that because the size of the router ID is the 32-bit and the configuration, the format of the router ID is in the IPv4. Then another interface, IPv6 AGRP 1. I think so. I think so. Router AGRP 1. If I'm not wrong. Let's have a look. On router 1. Yeah, I'm right. So sometimes even I forget the command line, man. So for the router number 2, we have a range keyword. I can use it. And I said for the 2, no, for the 2, it still have the same one, right? We have a single interface. Just last one. For 3, we have a multiple interface. For the 4, for the 5 and 6 as well. All done. So let's configure with the 2 now. Simple configuration of the EGRP if you compare with the IP static router. R3,
So we are not advertising any networks, right?
we are enabling the interface into the routing protocol. We are not advertising the network. We are just enabling the interface. Enabling the interface means advertising the route. Same like OSPF that we did in the class, right? You have ability to enable the interface or either you can advertise the route.
Okay, I see. So you can do either way, right?
But in the IPv6, you cannot. You just need to enable the interface. That's all done, right? So if you see that, why they're not forming the division. Why I don't see the neighborship, man? IPv6 router EHRP number 1, EHRP router ID 111, IPv6 router EHRP number 1. Oh wow, the command is not picking. Why? No net. There's some problem. Okay. Router usually. Oh shit. Interface 0/0 IPv6 PHRP number. Man, no the routers. So IPv6 PHRP that's the command. And for me, it's been a long time to do the lab of IPv6. So you can see that they are forming the neighborship, right? And they are forming the neighborship based on the link local address, as I told you that use case, right? Now, if you go on the router number 1 and have a look over there, so IPv6 EAGRP neighbor, I do have a neighborship of the R1 to R3. They are forming the neighborship with the help of link local address, not the global unicast. So that's a beauty case. And I can ping the neighbor. So if you see the so IPv6 route, I have a route for the different 2, 3, 4, and 5. On router 1, I can send the traffic to the 5 as well. I can send a ping 2001 DB8 cafe 005 colon colon 3. Sorry, it's working. So that's how you can enable the HRP, right? So how you can enable the OSPF protocol as well? So for the OSPF, a very simple formula. Let me go down and enable the OSPF. So first, we need to remove the HRP from every router, right? All done. So we are done with the HRP. Let's do the OSPF as well. So how you can enable OSPF? So the IPv6 router OSPF number 1, router ID will be 10101 and interface gig 0/0 IPv6 OSPF 1 area 0. That's all right. Same thing for the all the other.
We have to demonstrate the area as well.
We demonstrated if you see that area 0.
Yeah, but that means they all belong to area 0, right?
Right. So
If we are enabling the interface, then we don't have to be advertise the networks. Same question again.
same exactly right.
And you can do the same thing in a production environment.
Same thing in the production, but in the IPv6, you're not allowed to advertise the router with the network statement. You're only gonna do the with the interface command line.
But in IPv4, you can do that this
In
way.
IPv only, it happens in OSF protocol.
Okay, it doesn't happen in EIGRP and
No,
BGP.
it's not happening in the AGRP. It's happening in the AGRP. Or to think about it, in the name mode, no, in the name mode also, it's not happening. It's only
Sure.
happening in the OSF. All done, man. So let's wait for some more time. Two-way state. The DRBDR is going on right now.
Right.
So R5 has formed the two neighborship. Go back to the router one, so IPv6 root, and I can see that I have a route. I can see the two network. I can see the three network. I can see the four network missing with the five. Wait for some time. I got the five now. So from R1, I can send the traffic to the five as well. And I'm able to communicate from here. So if you see there is a something advanced level of thing is happening, so IPv6 is data is stable, you will see the LSA 8 over there. Remember, we have discussed the LSA 7 till this point. We have LSA 8, 9, 10 as well. We'll discuss this part in the C
Okay.
side. We'll discuss in the C side, don't worry.
No
Just to
problem.
show you that, nothing else. Okay. All done, man. So this is for the OSPF now. Let's do the BGP. So what I can do that for the BGP, I'll just show you the configuration between the router 1 and router. Let's do the
So
BGP complete.
you're doing all the advertising, all the protocol just for the learning purposes, right?
Yeah.
And
In CCI, we'll do the lab of each and everything in the advanced level.
that's fine. In real scenario, you just configure one of them. You don't need all of them.
Yeah, you're just doing one protocol.
It's just for the practice purposes only.
Yeah.
Sure.
But please do this lab. Otherwise, you will forget the again IPv6.
No worries.
I'll save the
So
notepad file to you guys, so you can copy the notepad file for you. So for the BGP, what I can do that first remove the OSPF protocol.
Mhm.
Simple command. All done. So for the BGP, what I can do that on router 1, router BGP, what AS number should I use? So what I can do that, I'll use the according to the AS number 1, 2, 3, 4, 5, 6, like that way. I said the neighbor 2001 GB8 cafe 001:3. That's the IP address of the R3. That's going to use the remote AS number 3. Address family IPv6. I need to activate this guy. That's all. Same for the R3 now we have. On a R3, they are going to use the different autonomous system. So for R3, it's going to use the AS3 and the 3. This guy going to use the 1. This guy going to use the 1. R4 now we have. On R4 we have router BGP number 4. Router ID will be 40404. And the 2001 DB R4 is going to form the neighborship with the R3. That's a 2 colon 3 is 3, and R4 also going to form the neighborship with the R5. 3 colon 5. Same way, it's also going to form the neighborship with the R3, also going to form the neighborship with R4. Simple one, not a hard. 4, and I just need to activate this guy as well under the address family of
No.
IPv6.
I think you made some mistake in R4.
Yeah, tell me where I made a mistake.
In R4, you set up the neighborship with the R3
Okay.
and R5, right?
Also, I need to do the R5 as well when I'm doing that. R5. That's good now. And I need to activate the 3 as well, right?
Just one moment.
Now it's good.
Just a moment.
It's good now.
When you think, okay, just a moment. No, in your for sentence of the configuration with 002 double colon 3 activate, you are doing with the neighborship with the R3, right?
Yeah.
So the address should be the
That's correct, right? There's a mistake.
no, that's fine. For R3. So you're doing. So when you're doing the remote AS4, right? Remote
Yeah.
AS4, yeah, I'm talking about other side, on the right hand side.
Okay.
So 003, that means 003.
003, that's IP address of R3 interface.
No, 003, that is the IP address of the
R5, this side you're talking about? Yeah.
yeah, R5. Yeah, that's right. Yeah.
That's going to use the AS number 5.
So how about the AS4? Again on remote AS4. No, no, I'm specifically talking about the R4.
There is a mistake R4 you're talking about. See, everything is correct, right? R4 is going to form the neighborship with this person. That's I define the command. R4 is going to form the neighborship with this person. That's I define the command. Perfectly fine.
Just one moment. Yeah, that's fine.
That's fine, right?
002, that is the router number 2. Okay, isn't it?
That is the router number 3.
Sorry, router number 3. And the remote AS should be 3. Okay, and the 003, that is the router number 5, and the remote AS 5.
Correct.
Okay, so 3 and 5 is just identifying the router numbers, right? The neighbor
Right.
router number. Okay, that's fine. No problem.
R5 is good. R5 right already. R5 is going to form the neighborhood 3, 4. So 3, 4 we have neighborhood 4, and R5 is going to form the neighborhood the 4, 6.
No worry.
We have a 4 over here, and this should be 6 over here. This should be 6 over here. That's good.
That's
Now, and this should be 4. This should be 6, and this should be Here we go, man. R6 is done. R5 is done, R6. Here we go. R6 is gonna form the 4, 5, 4, 5, and this would be 5. This would be 2. This would be 5 and 2.
R6 is going to make a neighborship with 4,
And 2.
with
R6 is gonna form the neighborship with the 5, sorry, 4 and 5.
okay.
Understood?
So R6 is going to make a neighborship with 5 and 2, right?
That's I did it.
So, with 5 and 2. R6, I'm talking about R6. R6.
R6 is gonna form the neighborship with the 4.5, 4.5
Right.
and 5.2. Correct one.
So, okay, so it's just making R6 making the neighborship with only 4 and 5, right?
That's all right.
So, okay, so what about 3?
Why it's gonna form the neighborship with the 3, man? EVGP, we are gonna form the directly connected neighborship, right? If you have a indirectly neighborship, then you can do that. But I just have a requirement of the directly connected, that's why. And the directly connected.
No, if you say
Okay, you tell me
oh,
R6, you're gonna form the neighborship with this person and this person. That's all right. That's not.
5.
You are gonna form the directly connected neighborship, not the indirectly connected neighborship. That's my requirement I have. If you have a requirement of the indirect neighborship, then you can do it with the 3. But I don't have a requirement.
So it's connected with the 5 and 2. If it is connected with the 5 and 2, right? So that means is a 0 4/4. That's fine with 5, and 0/5 with 2. Okay, so right.
Right.
Okay. Yeah, I got it now. Sorry. Okay, so first you set up the membership, then you just activated it basically.
That's all.
Okay, that was
Okay.
making me confused. Yes. Okay.
Now done, right? So R3 now we have.
So I mean, sorry. One more question.
Go ahead.
Apology. If you activate it, so why do you have to activate it? Because you have already
Because by default IPv4 unicast is enabled. You need to activate that guy. You need to say that, okay, I'm forming the IPv6 neighborship, not the v4 over there. Because the by default IPv4 unicast is enabled over there.
So when you are farming the membership, it doesn't mean it's activated. You have to manually
You have
activate
to
it.
manually do that.
But we don't do that in IPv4.
No.
No.
No, you are not doing in the NP label, but will do in the I label. I'll show you that.
No,
With the advanced label, things are different.
but generally speaking, we do that, right?
Generally speaking, we do that, but you haven't reached that point level right now.
That's a different scenario.
Yeah. R5, R6. And R2. You can see that R1 is forming the neighborship with the R3. R3 should be form the neighborship with the R1 and R4. Right? R4, if you see that, is forming the neighborhood with the R3 and R5. And R5 should form the neighborhood with the R4 and R6. And the last two is forming the neighborhood with the 6. That's all done of the IPv6. I'll save this notepad file for the name of the IPv6. I'll do one thing in a minute. I have to copy this notepad, copy, and I need to go in the base PC. And under the base PC, I need to save this. I'll save this file name as a Gary, not Gary, as a desktop. Routing, not the protocol, as the routing configuration. I'll upload this notepad file on the Google Drive. Then you can follow this one. Guys, questions? Anyone has a question? Nasir, you understand anything?
No, that's fine. Thank you so much. You making you did some. I mean, you did hard work for us today. That was a lot. So, if you please kindly upload into Drive, so I can
I've
do the lab.
uploaded right now. All the videos uploaded. Only the few videos are missing, like SD-WAN and those things. I haven't got the time. But yesterday
problem.
video also uploaded, and today also I'm gonna upload the videos again.
Yeah. So, I mean, after 1 hour, I will start doing the
Maybe
practice.
30 minutes max to max.
No, that's fine. I will take. I need a break as well.
Yeah. But do this lab, it's very important, okay?
Yeah, that's what I'm saying. I will do after 1 hour.
Okay, great. Okay, guys, I'll see you tomorrow. Not tomorrow, I think so, because